This is Chapter 6, Problem 20. In this problem, we have two boxes, a Cheerios box and a Wheaties box, the one having 1 kilogram mass, the other 3 kilograms of mass, and we're going to push it with a force of 12 newtons, and each box has some friction force with the floor. They want us to figure out the force from the Cheerios box, that's the smaller box, on the Wheaties box, the 3 kilogram box. In order to do this, we need to start by considering this to be one mass that is 4 kilograms. That's the key on this problem. If we consider it to be one mass at 4 kilograms, we can figure out the acceleration of both boxes. Since they're connected, they're going to receive the same acceleration. So the total mass of our system is going to be 4 kilograms, so that means that F net is equal to the mass of our system, 4 kilograms, multiplied by whatever our acceleration is equal to. That equals the force that's being applied, 12 newtons, minus the friction force. You see that our total friction is 2 plus 4, which is 6 newtons of frictional force. That gives us an acceleration of 1.5 meters per second squared. Now we draw a free body diagram for just the Wheaties box. It has mg acting down, has a normal force acting up. Don't have to worry too much about that because they gave us the friction, so we don't need to use the normal force. There's some force being applied that's pushing the Wheaties box to the right. And then there is a force of friction that's trying to hold it back, pushing to the left. Since we have the acceleration of the system, the 1.5 meters per second squared, that means we have the acceleration of the Wheaties box. That means that the net force on the Wheaties box is equal to the mass of the Wheaties box, 3 kilograms, multiplied by the acceleration, 1.5 meters per second squared. Sorry, this is going to get a little messy. That must be equal to the force applied, which is pushing to the right, minus the force of friction for the Wheaties box, which is equal to 4 newtons. Solving for the force applied, we get an applied force of 8.5 newtons on the Wheaties box. That means that the Cheerios box is pushing on the Wheaties box with 8.5 newtons. What's cool here is we can actually check our work and make sure that we did the problem correctly. Let's consider the Cheerios box now. The net force on the Cheerios box is equal to the mass of the Cheerios box, 1 kilogram, multiplied by 1.5 meters per second squared. Remember, both boxes have the exact same acceleration. That's equal to the force applied minus the friction force. And we know that the friction force, as I erase here, we know that the friction force for the Cheerios box is 2 newtons. So when we add those two guys together, we are going to get that the force applied is equal to 3.5 newtons. That's the force applied on the Cheerios box. 3.5 plus 8.5 is 12 total newtons of force. So you can see that the 12 newtons of force was applied to each box based on the amount of friction in the box as well as the mass of the box. So we did the problem correctly. Again, the force from the Cheerios box on the Wheaties box is 8.5 newtons.